There are so many amazing places and things to see on our planet. For example, the Hang San Dong Cave is the largest on Earth, or the halo effect, or, for example, diamonds. They're one of the most expensive gemstones in the world. In order for them to be born, so to speak, many different factors must coincide, from external conditions to time. But what if you try to find diamonds in a place where no one has ever tried looking? I'm talking about deep beneath the waters of the Mariana Trench. Unfortunately, there's no way of making this kind of an underwater trip. There are no Mariana Trench excursions available to anyone. But I can use scientific data, logic, and of course, a bit of imagination. But let's start with the diamonds themselves. To understand whether it's possible for them to form naturally at the bottom of the Mariana Trench, we first need to understand what exactly a diamond is all about. In a broad sense, a diamond is a form of carbon, the most stable form, which, under normal conditions, lasts indefinitely. Diamonds are the hardest of all minerals. They're at the top of the mineralogical hardness scale and are used as a cutting tool in many industrial fields because a diamond can handle almost anything. Most natural diamonds are between 1 and 3.5 billion years old. That is, they're truly ancient minerals. Many of them formed at a depth of 150 to 250 kilometers. That's 93 to 155 miles in the Earth's mantle, although some formed much deeper. For example, at a depth of 800 kilometers, or about 500 miles from the surface. Diamonds don't appear at these depths by themselves. They need a sufficient amount of pressure and temperature, under which the carbon atoms form a cubic crystal lattice. The formed stones are then carried to the surface by volcanic magma during the formation of diatremes, the explosion tubes or vents that magma forms when pushed up through the rock. Then people mine the diamonds. It's worth noting that diamonds are a rare but at the same time widespread and even popular mineral. Yes, this is the diamond paradox. Industrial diamond deposits have been found on every continent except Antarctica, and their mining began in the 9th century BC. About 26 tons of diamonds are mined annually for a total value of about 14 to 15 billion US dollars. And this isn't even counting synthetic diamonds, specially created in laboratories, which are also formed from carbon, crystallized in an isotropic three-dimensional form. According to various estimates, up to 98% of the diamonds used for industrial purposes are made artificially. And actually, that's not surprising. Considering the cost of natural diamonds, it wouldn't make much sense to use them, for example, in a dentist's drill. However, diamonds, oddly enough, can be found outside of our planet because in space there really are a lot of them. In meteorites, about 3% of the carbon is in the form of nanodiamonds, and some of the space diamonds studied by scientists were clearly formed outside of the solar system. Additionally, diamonds can also be present in carbon-rich stars, especially in white dwarfs. Honestly, I never suspected that the universe was so rich. Just imagine if people had access to even a fraction of these diamond reserves. Anyway, I got a little distracted. Let's get back to Earth. And not just to Earth, but now to the Pacific Ocean near the Mariana Islands, to the Mariana Trench. I suppose that almost anyone, even a little interested in the geography of our planet, knows that the highest peak on Earth is Mount Everest, and the deepest point is in the Mariana Trench. But what about the specifics? The Mariana Trench is a crescent-shaped depression 2,550 kilometers or 1,584 miles long and 69 kilometers or 43 miles wide. So, if you ever see photos of some kind of circular underwater hole called the Mariana Trench, that's definitely not it. The trench is located at the junction of two tectonic plates. in the zone of movement along the faults, where the Pacific Plate goes under the Philippine Sea Plate. The maximum known depth of the Mariana Trench is 10,920 meters. That's 35,827 feet. This place is called the Challenger Deep. The depth of the trough is often measured in Everests. The entire mountain would fit inside it with a couple of kilometers remaining above. You could even stack Mount Vesuvius on top of Mount Everest, and it still wouldn't reach the surface. Such a huge column of water can't help but affect the pressure. In the Challenger Deep, it measures 108.6 megapascals, which is more than 1,071 times higher than normal atmospheric pressure at sea level. That's 5 times the pressure created when a bullet hits a bulletproof object. At this pressure, the density of water increases by 5%. The bottom is pretty cool as well. Due to the lack of sunlight, which simply can't reach it, the temperature at the bottom remains around 1 to 4 degrees Celsius. That's from about 34 to 39 Fahrenheit. However, all of this still doesn't stop life from forming in the Mariana Trench. Even at great depths, worms, mollusks, deep-sea fish, sea cucumbers, and smaller forms of life can be found here. Scientists were quite surprised when they first discovered them. But what about diamonds? For this super hard mineral to form, there needs to be high pressure and high temperature. Regarding the latter, this doesn't quite work out at the bottom of the Mariana Trench, but maybe there's still hope. According to scientists' calculations, in order for carbon to become a diamond over time, a pressure of more than 4,500 megapascals is necessary. That's much, much more than in the Mariana Trench. In some cases, a lower temperature will suffice, but even then, the pressure would need to be at least 3,500 megapascals. The Mariana Trench still falls short on this key factor. But maybe it's enough to create synthetic diamonds. These are made using various technologies. One of them requires a temperature of 1,500 degrees Celsius, or about 2,700 Fahrenheit, and a pressure of 5,000 megapascals. Another method doesn't require high pressure, but it requires electricity, a laboratory, and in general, people. So, in the end, the Mariana Trench is completely incapable of forming diamonds. Time for the sound of a sad trombone. Even if diamonds suddenly abandon these conditions, the laws of physics and common sense, and began forming at a lower pressure, we would still have to wait a couple million years before the carbon transformed into a super hard mineral. And yet, this material still may not be characterized by that incredible diamond strength. Temperature and pressure play a decisive role. Well, now, since we've already begun fantasizing, why stop here? Let's suppose some really rich and at the same time very strange person wanted to produce diamonds precisely at a depth of almost 11 kilometers or about 6.8 miles. Why? Who knows? Let's say it's one of their childhood dreams or something like that. Would it even be possible to arrange something like this? Theoretically, yes. We would need to build some kind of modern underwater base, lower machines equipped with HPHT technology to the bottom of the Mariana Trench, having, of course, previously agreed on this with the rest of the world, and somehow connect and run the equipment. But we would still need to not only service the expensive equipment, but also remove the results, the diamonds. It's just too complicated. After all, the Mariana Trench isn't some office in the center of a metropolis. You can't just call an Uber to take you there. In the entire history of mankind, there haven't been many deep-water dives to its bottom, and this isn't by coincidence. Would it really be worth it? Absolutely not. Even taking into account the fact that diamonds created in the Mariana Trench could be sold for much more than conventional ones. So, if you suddenly find yourself with an obscenely large sum of money, it's better to invest it in something worthwhile. For example, a flight to Mars, or even better, the environment. In fact, even one of the most inaccessible regions of the world, the Mariana Trench, suffers from pollution. In 2016, a plastic bag and several candy wrappers were found there, and it's unlikely they were left there by some sea cucumbers. In the end, caring for our planet is much more valuable than any collection of diamonds. If you like this video, give it a thumbs up. Don't forget to subscribe to the channel if you haven't done so already, and click on the bell to receive notifications of new interesting videos that are waiting for you ahead.